Welcome to Object-Oriented Design and Programming. So, object-oriented programming is a paradigm in the perspective of a cooperative collection of objects, meaning everything is an object. Object is basically an entity that combines properties of procedures and data since they perform computations and save as a local state. Okay? Data is represented as a variable and procedure is referred to as a method. These are functions, right? So in OOP, data consists of data, right? Object consists of data, which are things or attributes, and part of it it's methods, which are the actions that it can do. For example, you might have some actions, right? You have an object with a line. The line has a shape, color, width. It can be actions it has. It's draw, erase, undo, right? So methods also allow access and to manipulate data within the object, right? Um, in the object-oriented design, we do want to have the data in abstraction, interface, and state. It means that we only want to show the user what it needs to see. It doesn't need to know the intricacies of the logic, and also the logic could be because that's where your money is, right? You don't want them to know your algorithm. Objects has an associative type, aka class, inheritance. So basically, you can inherit properties of a certain class and keep doing that, right? So OOP concepts, right? You have abstraction, polymorphism, inheritance, encapsulation, object, and class, and we'll discuss this more, right? A class creates an object, and class supports all of these: the abstraction, polymorphism, inheritance, and encapsulation. Class is a user-defined data type, right? Think of it as like a blueprint, like it's a building block for the objects. And for example, how can we define a car and its behavior? You create a blueprint for that car, a class, and it has the year, model, speed, color as the data, and the methods is the accelerate and brake, and also the get and set method. The get method is basically getting the information of the data. Let's say get model, and you'll get the model of the car. The set method is changing the data. Let's say you want to set a different color from red to black, you would set color to black, right? So a class in Python, it starts with the underscore in it, right? And another underscore, right? That is a constructor wherein when you instantiate an object, it will basically initialize member class variables and member methods. And the underscore delete is the destructor so that it can remove the things that you have allocated memory for, right? Again, with the color, here are some attributes and we'll move on. An object is identifiable instance of class. It has characteristic behavior, has data methods, and manipulated data. Yep. They interact without having to know the details each other's data or methods. For example, let's say the get model, right? Let's say it would interact with another object or method. That other object or method doesn't need to know what's inside of the get model as long as the other object assumes that it would just return the model. It doesn't care about how it does it, right? Okay, so another thing that we can do is objects are simulations of realities. Again, object-oriented designs are designed by the human mind, so they have this analogy or structure as well, right? So here, these are some of the notations that we use, right? Employee is a class name, and whenever you create a new employee, you instantiate an object, you create a new employee. This is just the blueprint, right? And the employee has attributes or characteristics. These are the data or things, right? And those data you can basically associate. These are metadata, and you can associate values to those data as well. And in this notation, beneath the second part of the box, below the box, is basically the methods. So Python supports many different types for sure, but again, everything is an object with Python, right? All the objects have the following properties: object types. Objects is an instance of a class. We already mentioned that. So x equals 153 is an object. It's an instance of the int class, meaning it's an integer object, right? Again, everything is an object in Python, right? So employee name is an object as well. It's an instance of a string class, right? You instantiate that. Different ways to look at the objects. Okay, we mentioned that. Abstraction hides all the details of the implementation. Easier to solve a problem, right? Again, the more abstracted it is, the less complicated it is to the user, right? Because they don't have to know all the details. Makes only relevant operations available. Think of your coffee machine. You just press on and off, maybe brew a coffee, and that's it. You don't even have to know that, okay, it first crushed the bean and then it does this and that, this and that, right? So classes implementation abstraction to two attributes, the member variables and the member methods, right? These are the data and the methods we mentioned earlier, right? So moving on. Um, so when designing a class, right, you wanna at least have the most relevant important when designing a class and the least relevant important when designing a class, right? And as you can see, what happens here is you first have to think about how to fit the bigger stones first, right? And then you put the sand, as you see in the second bottle. In the first bottle, what happens is the least relevant was put in first, which is the sand, and they started putting the stones, and now it doesn't fit in. Okay, let's look at cars. If you're a car enthusiast, you see what are the common themes here. You have the four wheels, you have the windows, right, and the doors, and you can abstract everything first, right? This is a class car, and things in action. Also, in this part, yep, we already saw that it's four wheels. Again, it's just 2D, you didn't see it. Has a window, and it should be having a door as well. So another example is how can you abstract the following objects in a class, things in action? So these are backpacks, right? And the first is, let's say you say that, oh, all bags, not backpack, all bags has straps, right? And it can be carried around in your bag. But the problem is, once we have different types of bag, let's say a luggage or trolley bag, now you're thinking, how should we design our um, bag class properly, right? And even at the bottom, you have like a shoulder bag, right? So these are some of the going back. These are things that you might need to think of how to inherit something, right? One of the most essential features of OOP is the abstraction. You show features and you hide the details. Okay, we already mentioned this, so we skip this. Abstraction arises from a recognition of similarities and differences between certain objects and situations, right? Through abstraction, we use chunks of information with increasingly greater semantic content. So, here's an example where we can group things together, right? Like the full name, address, phone number, SSN are important parts of what defines a, let's say, a person, right? And the other one is, let's say, the flight, right, object. These are the important parts. And the other three at the bottom is not relevant. Degree of abstraction, as you can see, it differs from different users, right? Drivers are what we call end users. They only need to know how to drive and maybe troubleshoot a little bit here and there if they encounter any problems. But if it's something mechanical or inside of the machine, we now have to go to a car shop and have a mechanic basically fix it, right? Because they do know the intricacies of the inside. And once they try to do everything but still does not work, it's now the time to check for the design of the car, if they really designed this properly and the designer has access to all of the attributes of the car, right? With no holds bar, they know everything there. Again, as we mentioned, more abstraction means less complexity. Less abstraction meaning more complexity. As you can see, the designer has the least amount of abstraction, therefore it has more complexity to deal with. Encapsulation is you wrap things in something, right? So member variables and methods are packaged together under a single unit class, binding together the data and the methods that manipulate them. Data abstraction or hiding can be implemented via encapsulation. Okay, you hide the details of the implementation. So abstraction and encapsulation complements one another, right? So abstraction is just a concept where we can use on many things, and encapsulation is more of in the object-oriented design, right? Implementation giving the behavior. So what operations can we expect from object manipulation? We can create a new object, you instantiate, right? Modify existing, you assign a value, you delete by delete, you include by importing. So once you have this kind of the blueprint of like the class, right, or object, you can basically import it anywhere in your code base, right? This behavior is defined by attributes, data type, member variable, even numbers, right? So let's say for Python, you do have a list, right? The list has certain methods you have already, but with the dot notation, right? So dot remove 4 removes the 4. Dot sort sorts the list. Dot pop removes something in the list. These are member methods. It's included in the list class. So abstraction, as time and again, similarities between certain objects, situations, or processes. Okay, moving along. Encapsulation, just a repeat of what we have. Inheritance, right? So this is don't repeat yourself. If you can create a very good class structure, you can basically inherit that, right? So always before doing things, you have to basically take into account similar objects, or in the future where you improve your program, right? You should think about those two, because reworking your class structure where you have deep inheritance is already it's gonna be a big task. So again, let's say you have inheritance, right? You want to create a base class where it's a very generic structure. For example, the base class is a vehicle, right? And the class car can now inherit the vehicle. The class truck can also inherit from the vehicle, right? Let's say both of them has 4 wheels, so if both of them has 4 wheels, you might want to put 4 wheels in the base class, right? And the car, let's say the car has passengers. Maybe the car is has a trunk, and the truck, let's say, doesn't have a trunk. Let's say it has a loader behind, right? Another example would be reusability for the inheritance, right? For example, you have bank account, and now from the bank account, bank checking account and savings account can basically inherit the owner balance data attributes, and also inherits the deposit and withdrawal. Again, the owner and balance are member variables, and deposit and withdrawal are member methods, right? And now, if the checking account inherits, they get it everything. Plus, you include the insufficient funds fee and process check and withdrawal. The same with savings account. You inherit everything in bank account, and you have annual interest rate, deposit monthly interest, and withdrawal. So here's another class. Let's say you have a point, and it becomes a point 3D, or the other way around, right? So as you can see, point has a data member called numPoint. It also has a constructor with def init. And what it does is initialize data member variables x and y, and also point.numPoint, right? It has member methods, such as print point, set point, and delete. Okay, so the point 3D is similar, and you have now 3 points in the axis, right? Instead of XY, you have XYZ, and you can create a separate class for that, right? But you can see a lot of similarities now. So the question is, would point 3D be a good way to be the base class and point would inherit it, or point class point would be the base class and point 3D would inherit from it? Okay, it's better to inherit from point to point 3D. The reason why is you are less specific, more generic, and that's usually better, so you can be flexible, right? If you started with point 3D, you are restricted to having the X, Y, and Z when you only need X and Y, okay? So inheritance, think of the real world always, because it's a simulation of the real world. Line has a shape, line has a point, doctor uses a patient uses a doctor. So you have, again, this inheritance aggregation association as well, right? Base class is the parent, derived class is the child, right? Polymorphism means that you have many plus forms. That's the word there, right? So a person can have different characteristics for different responsibilities. Work as a father, work as a manager, work as a husband, right? And different operations or behavior could be required based on different instances, aka data types. It is used quite often in inheritance. Suppose that employees get raised or promoted. Do we expect the same? Give them a member method raise salary, right? Between managers and engineers. Suppose you want to write a game programming. Do we expect the same for everything to have a member method with attack between ninja and monster, right? Okay, so as part of polymorphism, there's what we call overloading, right? It means that you can overload the behavior. For example, the plus, right? For plus, when you plus two strings together in Python, it basically does a concatenation. It does not really add like the values, right? It just puts them together. When you use the plus symbol on two integer objects, they would basically add the value, right? So there's another thing which we call method overloading and overriding. And overloading is basically having the same member, right? And having the same function name, sorry, and having different number of parameters. So as a demo, you can see here, this first one is the method overriding. And what it does is the print me was overridden, right? And at the right side, it's a method overloading. And what happens here is you have a compute area function, right? And you have compute area without a parameter, meaning an argument, right? The first one, and then the second one has an argument, the third one has two. So OOP keyword, class, blueprint, and object, example of a class or instantiation of the class. Abstraction, hide details, methods are functions, okay, but it's inside of the class. It's just another name. Data members are variables, but they're inside a class. Instantiation is creating an instance of a class that becomes an object. Yeah. So this is the syntax. You have the class keyword, right? You have the name of your class. You want to use a capital as the convention, and you do initialization with init, and make sure you have underscores when you use the name. Docstring as well to define what the class is. Okay, class variable, and these are data member variables. And these are these are member methods. Okay, another class demo. I guess this part is pretty self-explanatory, where you can basically instantiate the class and keep creating different objects with different data member variables with different assigned values to them. So instance variables are the values that are unique to each instance. For example, I'd like to name car's color in red and my Mustang's object of a car class. Class variables are variables that are being shared by all instances of the class. Okay. Every instance will have the same initial value. Okay. So iterator. So why? Iterator has some performance benefits, and I think we are here. We basically jump to um, instead of, so we've done list, right, and tuples and sets and string, right. We use the for I in range keyword, or for I in the name of the list or whatever, or the variable. And if you use an iterator, it's basically a member method or function already for the instance, so we can also use that to easily iterate, right. um, Performance benefit, large memory and speed usage. Usually it's already optimized, right. Small and not very obvious. So ways for iterating or traversing, you have the breadth first search iterator, where you go wide, right, before you go down. Depth first search is you go deep first before you go wide, right. So iterator, um, what you can do with iterators is use the iter, right, iter function, and you basically pass in the variable, which is in this case it's a set. You can print the next, keep using the next method, and basically it will print apple, banana, and cherry, right. Okay, so iterable. So the for loops are the iterables, right? The for keyword, and you can only actually use that if um, the things that the objects that we're gonna use are iterable, basically, or it can be loop, and these are lists, tuples, and strings, right? And we cannot iterate over an int object, just so you know. Okay. User defined iterators, so you can create your own iterators, right. Can create your own method, create your own class for that, right. And that should be the end of it.